everyone, this group demonstration video is prepared by Fatin Nur Izzati binti Mat Syukur, Muhammad Mirza Syahmi bin Muhammad Sanizam, Nur Syafiqah binti Muhammad Zabaidi, Nurul Farhana binti Amir Fazil and Wan Nur Mirza Akil binti Wan Nurul Azam. We are a bunch of students from AS 2014B1. Without furthermore, let's get started!
To begin with, Sds-Page stands for Sodium Dodecyl Sulfate Polyacrylamide Gel Electrophoresis, which is usually used to obtain high-resolution separation of complex mixtures of proteins, based on the protein molecular weight and the electrophoretic mobility.
Mirza, can I know what are the principles of SDS?
Yes, please. I want to know more about it.
Yeah, me too.
Sounds interesting.
Sds-Page principle states that when charged molecules are placed in an electric field, the molecule will move to the electrode of the opposite sign. In Sds-Page, SDS acts as detergent which breaks the disulfide bonds of the protein and eventually altering the tertiary structure of the protein with the help of some reducing agents. The ionic detergent denature and attach the protein masses and makes them to uniformly negative. Hence, along the electrophoretic system, the polypeptide's migration is determined by the molecular weight. So, smaller molecules, which has low resistance to the gel, will move more faster or quickly compared to the larger molecules. In this experiment, the materials and apparatus which are going to be used are as follows.
Procedure.
To begin the experiment, insert a short plate and 1 mm spacer plate into the casting frame. We must ensure the feet of the casting frame are on the bottom and level at the bottom. Next, tighten the clamp to secure the position of the plates. After finish, install the casting frame with the plates on the casting stand and make sure the setup is tight and secure. Pipette DD water halfway up the plate to check the seal of the setup. Next, we need to observe if any DD water leaks. If no leaks, remove the DD water either using Kim wipes or filter paper until it is almost dry. When the gel casting stand is set up, prepare 12% resolving solution in a 50 ml Falcon tube. Next, mix 3.3 ml of DD water, 4 ml of 30% acrylamide solution. Make sure to wear a nitrile glove when handling acrylamide solution as it is neurotoxic. After that, add 2.5 ml of lower stock and 100 microliter of 10% SDS together. Add 10 microliter 10% APS before pour the gel and also 4 microliter of TMAT. Due to its strong odor, TMAT has to be added in the fume hood. We add TMAT later to avoid the gel from setting up before it is ready to be pipetted in between the plates. Then, mix them gently. Immediately, pipette the resolving gel solution in between the plates using glass pipette until the resolving gel reach above the green line or approximately 1 cm from the top of the short plate. We must ensure there is no leak at the bottom of the isopropanol on the resolving gel. Then, observe a thin layer on the gel.
While waiting for the resolving gel to polymerize, prepare the stacking gel solution in another 50 ml Falcon tube.
Mix 1.35 ml of DD water, 0.335 ml of acrylamide stock, 0.25 ml upper stock, and 20 microliters of 10% SDS. Once the resolving gels has formed, drain the isopropyl. Gently rinse the top of the gel with DD water and dry with Kim wipes. Right before you're ready to pour the stacking gel,
Add 20 microliters of 10% APS and 2 microliters of timid into the stacking gel solution and mix well. Immediately pipette about 1 ml of stacking gel solution on top of the resolving gel in between of the plates. Fill to the top, then insert the comb into the solution. Wait for the gel to polymerize. After the gel is formed, unclip the casting frame with the gels from the casting stand. Then, carefully remove the glass plates from the casting frame.
Wrap plate in a wet paper towel plus saran wrap and store in the cold room until next week. Sample preparation.
To prepare samples for Sds-Page, label the microfuge tube corresponding to your samples. Pipette 40 microliters of the extract into the microfuge tube and then add 40 microliters of sample buffer. Heat the tube at 100 degrees Celsius for 3 minutes and then centrifuge for 5 seconds. Remove the gel from the saran wrap and paper towel. Tightly secure the gel with the short plate facing inwards onto the running module. Each running module can hold 2 gels. If only one gel is being run, you will need to use the buffer dam in place of the second gel.
Do not directly label your plates with tape because this will prevent the gel from running properly. Instead, plates can be directly labeled with a permanent marker.
Each tank can place 2 running modules, which will be 4 gels altogether.
Insert the running module into the tank. Make sure the module properly inserts into the slot in that particular tank. At this point, check to see if the lid fits properly. Then pour the 10 times diluted running buffer solution into the running module between the 2 plates until wells on the 2 plates are fully submerged. Try to make sure the running modules are leaking any buffer solution into the tank. The tank only needs to be filled halfway with the buffer solution if running 2 gels. Remove the comb properly so we can see each well clearly. We can install the loading guide on the gel to make it easier to load your samples properly into each lane. Carefully load 10 microliters of sample solution into each well. The pipette tip should be inserted into the well in between the plates, deep enough to prevent overflowing of the sample to the neighboring lanes. Slowly release the sample solution into the lane, and when complete, remove the pipette tip, change the tip, then load another sample. For the molecular weight marker, we can also need to load 10 microliters into the well, and it should be loaded in one of the center lanes for easy comparison. Set the power to 20 milliamps per plate and run for 1 hour. For example, if 4 plates are being run, the power should be set at 80 milliamps. The power can also be set to voltage. The voltage used isn't dependent on the number of plates, so a consistent voltage can be used to run any number of plates.
So you should initially observe the sample or standard solution to be condensed into a thin band through the stacking gel. Then the band will gradually migrate down the resolving gel. When the blue dyes have reached close to the bottom of the gel, stop the run. Unplug the power supply, then remove the running module from the tank and drain the running buffer. Remove the glass plates carefully from the running module. Then carefully use the gel releaser to remove the gel from the glass plates. You can trim off the stacking gel carefully before proceeding to staining. Transfer the gel into a square Petri dish. Then pour the Comasi blue staining solution into the Petri dish, submerging the gel fully. Place the square Petri dish in a metal tray to avoid spillage in the incubator. Then place in a 50 degrees Celsius incubator to stain for 30 minutes. Remove the gel with a tweezer and make sure you can observe clear bands on the gel. Before discarding the staining solution and replacing it with the destaining solution. When destaining, add a piece of kimwet or absorbent paper towel to help absorb the dye. Destain at 50 degrees Celsius for 30 minutes with periodic swirling to facilitate the destaining process. You may also want to change the destaining solution every 15 minutes until the background of the gel is transparent. When the destaining is complete, store the gel in DD water until you can scan and analyze it with the densitometer. Properly dispose of any liquid acrylamide containing solution in the acrylamide waste container. Polymerized gel can be disposed directly in the garbage, while staining and destaining solutions can be disposed into the non-halogenated waste container.
That's the end of our presentation. Thank you for watching and bye!